And let's get it moving to our second question. We have, what is the antiderivative of e to the power of negative x? Antiderivative Antiderivative is a fancy way of saying integral. In the same way that you could say the anti-integral is the derivative, but people don't typically say that. Anyways, the antiderivative is equal to the integral, which means that this question is essentially asking us to take the integral of e to the power of negative x dx with respect to x. Okay, so let's think for a moment. It tells us antiderivative, so that kind of gives us a hint of how we could handle this question if, let's say, we didn't know what the integral was. So we got to find d by dx of, let's call that square, is equal to e to the negative x. Now we know that to take the derivative, e to the x derivative is e to the x. Or I'll say it like this with the chain rule, because we do have a -1 factor in front of that. So let's say we have d by dx of e to the f of x. That is equal to e to the f of x. The power is unchanged, multiplied by the derivative of the power. You see how the power is f of x here? You multiply the whole thing by the derivative of that. So we see that here the derivative of this, like the power is never going to change between differentiations. So we know that its previous thing that we started from is actually, let me move some things around. Whoops. Technical difficulties, my bad. Yeah, just gonna move this like over here. Okay, technical issues resolved. We know that we are going to get d to the dx of something. Let's just call that a for now. Multiplied by e to the negative x is equal to e to the power of negative x. Sounds good? So basically we're trying to find what a is so we can find the original. So if we do this, we know that we can just like move out the constant a in front. D over dx of e to the negative x equals e to the negative x. Let's take the derivative of this. So that would be, with our little chain rule up here, we have a as our mystery factor before, because we're basically trying to solve for that, times e to the power of negative x times the derivative of negative x, so that's -1. Derivative of the negative x, that's the power, is equal to e to the negative x. Okay, now let's expand this out. So we have negative a times e to the negative x equals e to the negative x. We're solving for a. And we know that for this to be true, we conclude that a is equal to -1. Meaning in here and here, let's put these puzzle pieces together. We get negative, or d over dx of negative e to the power of -x is equal to e to the power of -x. Looks about reasonable. And of course, like if we followed the calculation, we would find that these two are equal. So when we found, we're looking for the antiderivative. So basically that's just saying, find something that where you take the derivative, you will find e to the -x. We found that the result of that is -e to the power of -x, which is the same as what you would get with the integral. The integral is just like a more formal way to say it, but a lot of the times when you're just being introduced to the idea of integrals, some people would like to call them antiderivatives, because it is very important to know that integration and derivatives are opposite operations of each other. Kind of like how multiplication and division are opposite operations of each other, derivatives and integrals are opposite operations of each other. And that is actually the fundamental theorem of calculus. It's very important to know. So reading through the solution that we get here on OneClass, actually an important thing that we need to know is that like with the antiderivative it does work, but if we were to say integral, we would be more important to have a plus c constant here. So instead we'd want to have like d over dx negative e to the power of -x plus constant of integration equals e to the -x. Now the reason why we need this constant of integration is, like, let's say we have -e to the power of -x, and let's say c is like, you know, a nice friendly constant number like 21. If we take the derivative of that, like we'll take the derivative of both these terms individually, the constant is going to zero itself out and it's not going to appear in the next term. But let's say if we're taking the integral once, let's say we need to take the integral again, like this c would come from something that's higher order. So that's why we need to have the constant of integration when we take the integral. But I suppose when they're asking for antiderivatives, that's like less explicit. When you're asking for integrals, always make sure you got the plus c. If you don't see the c, you're going to see some d's on your report card. So, you know, it is what it is. Don't forget the c's. Okay, let's verify the solution here so we can say the above solution is correct. Nice. Let me just clean up our whiteboard here. Our whiteboard. Solution is good. Cool.